Afternoon and welcome to all of you who've joined us on day one of NASSCOM's NLP week, an exciting area of discussions delving into the NLP opportunity that is ahead of us in India. This is Asna Siddiqui. I'm your host for today, and I'm truly excited to be in the midst of the stalwarts of the field in today's session. I'm delighted to be introducing Mr. Manish Gupta, our keynote speaker for today. He is the Director of Google Research India. He holds an additional appointment as an Infosys Foundation Chair Professor at IIIT Bangalore. Previously, Manish has led VideoCan, a video technology startup, and the research centers for Xerox and IBM in India. Manish holds a PhD in computer science from the University of Illinois. He has co-authored about 75 papers with more than 7,000 citations in Google Scholar in the areas of high-performance computing, compilers, and virtual machine optimizations, and has been granted 19 US patents. And with that, I want to invite Mr. Manish Gupta to begin the keynote session. Please.
Thank you, Asna. Again, it's a pleasure to talk about our work on natural language understanding, and this is all I'm really representing the work done by our team. So all of us, I think who are probably attending this conference, we are all used to using Google search whenever we need any information. Often the first thing I would do is, type it up on Google. So the question that we asked is, how do we provide the same kind of access to information, right, that you and I take for granted to everybody in India? So it shouldn't be just people who are familiar with English, but also people who want A, to access information in their native language, and B, who may not be very comfortable typing things. So we also have the Google Assistant product, which is available, which is able to respond to queries in voice. And in fact, it supports 9 Indian languages. And in fact, Hindi happens to be the second most used language globally after English. However, I'll be the first to admit that most of these products, Google Search, Assistant, they work very well for English. They don't work as well for most Indian languages. There's a lot of room for us to improve. So, of course, India presents a very interesting, amazing and fascinating opportunity to us as researchers, right? Because of our rich diversity of languages that we speak. I have some numbers here, that there are over 20, there are basically, apart from the 22 official scheduled languages in India, we have over 100 major languages, and in fact, several scripts, and also we are a very multilingual society. Often we do what is known as code mixing, which is mixing up multiple languages in the same sentence, and code switching, right? We switch from Hindi to English or from Tamil to English and so on, in the same sentence. So what that means is that if you're just providing, let's say, a capability for search or responding to queries in a given language, it's not just enough to support a single language. You have to be able to now build multilingual models which are able to respond to these queries in a combination of different languages. And as you go about building these models, again, there are so many different languages, and often in natural language processing, there are different kinds of tasks, right? There is things like named entity resolution, there's sentiment analysis, and so on, different kinds of tasks. So to be able to train each of these models for every language, it's a great deal of work, right? And each of these requires a lot of label data, and often we do not have the luxury of having all of that label data available for every language, for every task, and so on. So what we have been looking at our lab at Google Research India is to really look at, so our overall mission is to really significantly advance the state of the art in Indian natural language processing and ultimately democratize access to information for Indian language users. So we want that laborer's son in Chhattisgarh or that farmer's daughter in Assam to be able to access that same information on the web, right? That you and I take for granted. And here again, on this chart, I've listed that often, I mean, when we as Google, let's say support, let's say top 10 Indian languages, we still leave out many, over 100 million speakers, right, who are speaking these other languages, which tend to have much fewer resources associated with them. And of course, the other challenging aspect is that while we can say, yes, we have a model, speech model, and likewise various NLP models for Hindi, Hindi itself is often kind of composed of several related languages. The Hindi that's spoken in Haryana is very different from the Hindi that's spoken in Bihar. And there are, again, related languages like Maithili and so on, which, again, sometimes our products have a challenge in terms of being able to process those very well. So what we've been doing is, again, trying to see how we can build multilingual models for various tasks. The task could be something like named entity resolution, where, let's say, given the sentence Karan bahut khush hua, you want to recognize that Karan is a person. You want to recognize the sentiment, that this is a positive sentiment, that Karan is very happy. And again, the way we have been doing this is, what we did was we started with the multilingual version of BERT that was built at Google. BERT, as many of you, I mean, who are NLP enthusiasts, you must be quite familiar. I mean, just a quick thing on BERT. BERT was introduced by Google Research several years ago, where they looked at, again, I mean, these standard ways of doing self-supervised learning, where kind of you mask out certain words when you take these large corpus of text. You mask out about 15% of the words. Think of that as, let's say, fill in the blanks, right? That we used to work on those problems as school kids, where the teacher would ask us to fill in the blanks on some text. And the idea was that by filling in the blanks, they were testing our understanding of the language. So likewise, when you make this deep neural model, figure out how to fill in those blanks, it is really learning these models for the languages. So when we looked at the multilingual version of BERT, which had been built on over 100 languages, we found that its accuracy on Indian languages was quite low. So then we went ahead and built what we call Mural, which is multilingual representations for Indian languages. And we, in fact, have released these embeddings on TensorFlow in the open source. So BERT is, Mural has been built again on 16 Indian languages and English, and it supports both native and transliterated text. And what we have seen is, we have seen fairly significant improvements in various NLP tasks like named entity resolution, part of speech tagging, and so on both native. So on native, we saw something like an average of 10% improvement in the F1 scores over multilingual BERT. And for transliterated text, we saw an even bigger improvement, close to 27% improvement in the F1 scores for some of these tasks. So what we've been doing is also looking at a lot of real logs on things like Google searches as well as Assistant. And one of the things we noticed was that often we are seeing various misspellings or mispronunciations, which are very much influenced by the native language of the users. So look at the example over here, double bed furniture. Now this particular spelling may look very odd to any native English speaker. It would not be the typical way in which, let's say, somebody would misspell the word double or misspell the word furniture. But when you look at kind of phonetically, it actually makes a lot of sense, because if you were kind of internalizing some of these words, right, in terms of, let's say, Hindi, and then converting that kind of text uh, 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 simply in phonetic terms, right, to English, these spellings actually are not unreasonable. And the other interesting thing that we saw is further misspellings that happen that may be influenced by your native language. So again, I have examples like designer, lenga, where somebody might again replace S or Z in a given word by the letter J. Likewise, I mean, you may, I've seen actual menus in restaurants where motor paneer was kind of whatever spelled as motor paneer, which again might be because of the influence of your native language. So what we have been looking at is how do we again make our speech recognition and query processing systems be much more robust to all of these different variants. Because, I mean, if you only train all of these models based on the formal text, you are missing out on the real world usage of these words. So what we have been doing is working again with our, again, teams based on working on products like search, assistant, and so on, and speech recognition to be able to make these products robust to all of these different variants of these words. Another aspect that we've looked at is when you're doing things like translation of subtitles, especially in educational videos. If you just simply do a literal translation of these videos. So here I've taken some examples from the NPTEL videos that have been created by various IITs covering different engineering courses. And if you start with something like, again, an English sentence like, let us start our course in machine learning and deep learning with Python. And if you literally translate this sentence into Hindi, you will translate again machine learning into or deep learning into something like Gehen, Seekhne, and you will translate Python into Ajgar, right, which is the Hindi word for the animal. Whereas what you are really referring to here is the language Python, not the animal Python. So you want again your system to recognize these entities and in fact use perhaps carryover, right, the original name Python in these translations instead of doing those literal translations. As well as we have seen, I mean, often there are technical terms which start to get something like ReLU from the deep learning literature, which starts getting mapped into and kind of multiple words, which would occur more kind of in the formal language, and so on. And often there are problems in being able to recognize numbers and digits and so on. So that's another, again, line of work that our team has been doing on doing this entity-aware translation, both for things like videos as well as for even queries. One last example I'll give of some work we've done is this is part of our AI for Social Good effort, where we collaborated with this NGO Pratham Books or Story Weaver. What they do is they have been creating children's story books in different languages. So one of their efforts has been to try and preserve some of the languages which are at a high risk of going kind of extinct, right? Just like we talk about species going extinct and how important conservation is to preserve those species, they've also been looking into and thinking hard about how do we avoid some of those languages which have, in some cases, fewer than 1 million users? How do we prevent those languages from going extinct? So one area that kind of where we launched a partnership with them was on, again, creating tools. And meanwhile, even, I mean, and these are not languages about to go extinct. I mean, these have a fair number of users. But for languages like Maithili and Konkani, again, we worked with them and a team from IIT Madras on creating, again, better tools for input of these languages. And again, we made these transliteration tools available to folks from Storyweaver, which again led to very significant improvement in the accuracy of the transcription that they were able to do. So I've given you kind of a peek at some of our preliminary efforts around trying to democratize access to information. It's a very, very exciting area given the rich diversity of Indian languages. But we also recognize that we have a long road ahead. So we've been, again, looking for, again, working more closely with the community, with the research community on advancing the state of, again, Indian NLP. We are committed to releasing more and more of some of these tools in open source. So we made a small start by releasing these mural models on TensorFlow. And we are, again, also very interested in ultimately working with the government and the research community on creating more open data sets for different Indian languages and everybody kind of benefiting from being able to build better speech models, better NLP models on all of these languages. So with that, let me stop and take any questions.
Thanks a lot, Manish. That was very helpful. What you mentioned about entity recognition in the context that it is being spoken of is very relevant, and that's something that I'm sure we have a lot of ground to cover. And with that, I just want to quickly take on questions that are specifically being directed from the context of this discussion. I have one from Mr. Sushil Ostwal. It says, can we use open source library open sourced by Google to convert multilingual language, which is in audio, into text?
Sorry, I couldn't, there's some problem with audio. Can you repeat the question?
Yeah, sure. It says, can we use open source library, which is open sourced by Google, to convert multilingual languages from audio into text?
Yeah, so for speech to text, there are a lot of open source tools available. I mean, those are not from Google. I mean, I know about, I mean, prior to joining Google, when I was doing my startup, we were using some of these tools. Both there's been that Kaldi framework, and then there was also this, I'm trying to remember the name of that framework, deep speech from Baidu, right? That we utilized, which is, again, so there are a number of open source based frameworks that are available to take you from speech to text, which you can utilize as the starting point.
Sure. Before we continue, I just want to mention to everybody that Ms. Simi Chaudhary unfortunately couldn't make to this session because of a conflict. We deeply regret this, and we'll continue on to the other section, which is role of R&D in the success of NLTM in the fireside chat. So before we wrap up, I also want to just take one more question from our audience members. Are there any attempts, Mr. Manish, are there any attempts at Google Research to explore using icons to simplify language learning?
using icons.
Yes.
I mean, there is a fair amount of work now being done to look at kind of how do we combine our techniques in computer vision and marry them with techniques in NLP. On icons, I would say there is definitely work happening right now. I mean, in things like trying to recognize sign language. This is more for accessibility reasons. Can you convert kind of sign language into, again, can you into text? So I know there's a fair amount of work happening over there. We are also looking at, again, icons more in the context of, again, I mean, storytelling and so on, but I mean, uh, uh, not directly, right? To just simply convert into text.
Sure. We are receiving a lot of questions and some very relevant ones. I'll just pick one more. It says, it is from Mr. Muthian Chokalingam. He says, I'm currently working with ASR and would like to annotate for training the data. Can you please let me know what is the good annotation platform for ASR?
I'm sorry, I may not be the best person to talk about the specific commercial products that are helping you do that.
All right. Another very interesting one from Ms. Swati. She's asking about the technique used to know the tone of a word. Like when we type wow, it only produces wow, not wow with an exclamation mark. And what is the technique used to do it?
Yeah, so the usual techniques are kind of you start with label data where kind of uh, you analyze text where you also have the labels available for that text, and then you typically use the supervised learning techniques. So that's the usual method. So as you start building multilingual models, you're also looking to be able to transfer some of this learning, right, from one language to another, and that's where some of these again transformer-based systems like again BERT help you, where as you kind of mask out various words and so on, right? You're trying to learn robust models by looking in both directions, not just text that precedes, but also text which is following those masked words. And again, I mean, what researchers have shown is by building these kinds of models, right, on large kind of multilingual corpuses, you're able to bring the overall performance, right, of then you're able to later fine tune these models for specific tasks, right, which could be your sentiment analysis tasks or name entity recognition tasks and so on. So you're able to then do further fine tuning, but starting with something that has already been pre-trained on large volumes of data.
Sure, thank you. I would encourage everybody in the audience to type in their questions, and our team will endeavor to answer them all through text. And with that, I would like to thank you, Mr. Manish Gupta, for taking the time and explaining the conundrum, which is the formal versus real world text translation and interpretation. I think that's a real problem that has a lot of opportunity for India. And with that, I want to introduce Mr. Indrajit Basu, who's going to be moderating our fireside chat, which will be on the role of R&D in the success of NLTM. Indrajit Basu is research lead at the Center for Internet and Society India, where he focuses on the geopolitics, constitutionality, and policy implications of emerging technologies. In addition to his academic research, his writing and public interviews have appeared in platforms such as Economic and Political Weekly, The Hindu, Medianama, Analytics India Magazine, Times of India, among others. He's a lawyer by training with degrees from NUJS Kolkata and University of Cambridge. So with that, I want to invite Mr. Indrajit Basu to take from here.
Thank you very much, Asna. And it's a great honor to be hosting this fireside chat with a stalwart in the field, Professor Rajiv Sangal. No introduction can do justice to his career over several years, but I will try. Professor Sangal works on processing of human languages in computational Paninian grammar, the CPG framework, particularly applied to Indian languages. His team is building machine translation systems among Indian languages and from English to Indian languages. He also works on knowledge representation, information extraction, and search engines. He has authored 3 books and a number of research papers in natural language processing and artificial intelligence. And he has played a key role in shaping a new research university, which is Triple IT Hyderabad. Welcome, sir. Thank you so much for taking our time to chat today.
Yeah, thank you. Good afternoon.
Good afternoon, sir. So just to start off, before this chat will of course focus on the role of research and development in the success of the national language translation mission. But before we get into this specific topic, if I can just ask you for our audience today to summarize or introduce what the NLTM is. It's of course one of the important programs put forward by the Ministry of Electronics and Information Technology, MITI, in the government of India. But could you summarize for our audience what it's really about and what are the different stakeholders involved in this important initiative?
Sure. So NLTM is the National Language Translation Mission. So this mission has been launched now with the budget, and the goal of this mission is to produce translations of both written as well as spoken material. So for example, if you are listening to a lecture and you turn on the software which is going to be developed, then it'll start translating and speaking out in another language. So Hindi can get translated to Tamil, English can get translated to Marathi, and so on. If you look at the situation in the country right now, it is an unprecedented opportunity. We have devices in the hands of common man. There are a few hundred smartphones, which are really computers in the hands of a person. With those smartphones, people access internet, and to their not so surprise but frustration, they find that most of the material is not available in Indian languages. Most of the material is in English. It is quite shocking to know that less than 1% of the material on the internet is in Indian languages. All languages, all Indian languages combined. Actually, it is 0.2% of the material on the internet. And if you see the population, you know, something like 16 to 20% of world's population, that much material should be there. So we are 100 times below what we ought to be. So this mission has been launched keeping all this in mind. Now, if you look at the technology, then the technology readiness level is also unprecedented. So if you want to translate, if you want to recognize speech, you want to translate from one language to another, and so on, technology is almost there, but not quite there. So if you actually run a translation tool today, it gives you a translation, but it is not quite correct. If you tell a publisher, would you like to use this automatic tool? They say, no, thank you. It has too many errors and we can't do it. So text-to-text translation has that problem. If you look at automatic speech recognition, there again, the quality has really improved enormously, but it's still not practical to use it in different settings. So if you say general speech, it runs, it works. But when you go to, let's say, any domain like engineering or humanities or art or politics, you find that suddenly the vocabulary comes in the way and the speech recognition system starts making errors. So while putting together this mission, we looked at all these issues. So we said technology is there in the hands of the common man, telecom infrastructure is there, the content is there, but in other languages, not in Indian languages. And the technology is almost there. So if we put in the right effort and take the right decisions, then we can build a technology that will go out in the hands of common man, and the content will be increased, will become accessible to common people. So this was the idea behind the mission. And in this mission, two things have been looked at very carefully. One about the research and development of the technology, because if there is no technology, if it doesn't work, then it can't be used. So development of technology is one priority. At the same time, and this is not very common with research projects, in this case, at the same time, the technology must also reach out to people. So very strong emphasis has been built into this mission, into taking the research outcomes and giving them, disseminating them and making them available to common people through startups. So the technology gets transferred to startups or established companies, and then they make this technology available to others. They use it to produce translations, and all this material then starts going on the net. And we hope that at the end of the mission, the content that will be, go up, it will go by a factor of at least 10 or 20, if not 100. 100 is still a goal. It will take a longer time. It's a 3-year mission. And in these 3 years, we want to produce technology that will make a difference. It will increase content. It will make all this available to common people.
Thank you, sir. I think that was a really comprehensive summary, and it's something that really will enable India to be a global leader in that sense. This sort of a mission, the success of that, as you were saying, there is the enough of focus or enough of availability of Indian content is not there, and really in that sense it'll change if once this mission is successful, it'll really transform India's role, and other emerging economies can aspire for this sort of a mission. So this is really great. So let me kind of go a little bit deeper into the kind of ecosystem of the NLTM itself. So you mentioned startups and you mentioned R&D in general. So what I wanted to kind of pick your brains on was we have several institutes of research. One of them, of course, you've been involved with in India, and there are also several startups that are working on these issues. So when we look at the ecosystem of the NLTM, of course, the government is an important or kind of the founding stakeholder, but how do you see in the short, medium, and long term, the different parts of this ecosystem coming together to make this mission a success?
So on one hand, the idea is to do research. On the other side, the research need not be done only by a few players. The idea is to involve startups, even involve individuals, no matter where they are located, to participate in this research. So one of the strong elements in this project, in this mission, is to have challenge rounds by which different parts of the technology we will pose as challenges, and people who fulfill those challenges and they become leaders, they are very prominently recognized, and the technology which they have, which they develop, this can now be pulled together into a bigger system which has all the different elements in place. So here the idea is that in research also many people can participate. In this area, data is extremely important. The availability of large amount of data is what makes a difference. So it could be labeled data. For example, you have parallel sentences between English and Hindi, English and Bengali, and so on. And if you have parallel sentences, then machine can learn from that. Similarly for speech, so this was what I mentioned was text to text, but similarly for speech, if you have labeled data for transcribed data for English, for Indian languages, also for English spoken by Indian speakers, then we will build better systems for speech recognition, which will help in building the translation, speech-to-speech translation systems. So first I should mention that speech-to-speech translation system as such, in a form in which we are visualizing, it doesn't exist anywhere in the world. So what exists are different components, and one can try to put together those components. So the strategy for the mission is, short term, medium term, and long term. So in the short term, the idea is that we take 3 existing technologies. So for example, we take automatic speech recognizer, then we take text to text machine translation, and then finally text to speech system. So for example, if you wanted to translate from English to Hindi, then we will have an English speech recognition system. It'll take the input speech in English and produce English text, English transcript. Now that transcript, that text is then fed into machine translation, which would then produce a target language, let's say Hindi. And then once Hindi is produced, then you give it to a text to speech synthesis system. So it will take that text in Hindi and speak it out in Hindi. So what you have is a translation from speech to speech. So the idea is that first, short term, we will take such a system by putting together these components. Now, if you put together these components, system doesn't work automatically. In fact, there are a large amount of errors that come in. It is well known that when you have speech, you will have disfluencies, you have pauses, you will have words which didn't come out very well, or the speaker repeated a few words. Now, if you are taking a dictation, perhaps you can live by those errors, but when you translate, then, and machine translates, then if there is garbage in, it will be garbage out. Or even if there is a small error in the input, the errors in translation will multiply with that, and the final output text will have lots and lots of errors. And then finally, of course, it has to be spoken out in a natural way. So still the idea is that we put together such a system immediately within a few months of launch of this mission, let's say within 6 months, and within a year we put it to use. So we transfer the technology to startups, we transfer the technology to in the market, so that people start using it. Now here, how would one work with the machine, with the errors that are made by machine? So that is where the man-machine system or human-machine system will be put together. So where machine makes errors, the human being will be able to make corrections. And so that correction can be done at the first stage itself, when you recognize speech. And then after, in the translation, text-to-text translation, the correction or post-editing, as it is called, could be done by a translator. And then finally, the machine will speak out the text in the target language. So in the first short term, the idea is to put together. Now, if you want to apply it to an application, let us say we want to translate lectures in engineering. So NPTEL lectures, or lectures in higher education, in sociology or political science, under SWAYAM of UGC, or whoever else, or if you may want to listen to a TED lecture. But first, so if we can identify the domain of the text, the domain of the speech, of the lecture that is given, then one can take advantage of that knowledge in loading the translate terminologies, loading dictionaries, and then using them to produce better quality. So here is a machine that will constantly learn. So as you start translating, and there is a human being that is translating. So first few lectures, the human input is more, but as the translation starts getting produced in that domain, then machine starts learning from that, and suddenly the human being finds that the machine has improved. It is now producing better quality, and therefore productivity of the translator goes up. So we have tried to build this mission that in the short term itself, it is ready to go into the market. Immediately, it is something that starts getting used. And one thing we should understand with artificial intelligence, and it holds for natural language processing, of course, that any such system can be improved in perhaps 100 different ways. But which way is most important from the point of view of users, or from the point of view of economic feasibility of the task? Now, this is where the effort needs to be channelized. So we hope that right in the first year with the feedback, we will be able to channelize research effort to make things even better. And machine learning that was working with domain, it will also start working in other areas. So this is the short term. And the medium term, one thing we should understand that when you take a dictation, you throw away a whole lot of information. For example, if something is spoken out and you have to transcribe it, you write it, a lot of information gets thrown away. You know, for example, take this sentence, bhago, mat jane do, right? Stop that person, don't let him go. You run and stop him. And look at this other sentence, bhago mat jane do, do not run, let him go. Just the opposite meaning. And this is produced just by putting a pause. Depends on where you put the pause. Bhago mat jane do, bhago mat jane do. Now, if you have a normal automatic speech recognition system, now that system will simply produce text. And it is hoped that whoever will be working with that text, whichever person is doing that test, he will understand, he or she will understand. Now, suddenly when you say, no, no, this is going to be translated by machine, then machine can go completely wrong. And the output that is produced will not even be recognizable of where it has come from. So the output at the output end of the translation, suddenly the listener in the other language would say, oh, what has happened here? This is not making any sense. Now, so this is the problem. So we may need to redesign the technology of speech recognition, which does not throw away this information. It has pauses, and pauses are of certain, several different kinds. It captures the emphasis that can be put by increasing the volume, or it can be put by tone, by pitch. And it also should remove repetitions of words so that the words which got repeated can be removed, otherwise translation goes wrong. So the speech recognition system for machine translation, or for machine use, I should say, is required of a higher order than an ordinary speech recognizer. So in the medium term for me is 3 years, short term is 1 year, and long term is just 7 years, not 20 years. So 1 year, 3 years, and 7 years. So in the medium term, we would be working on each of these components. So we will be working on automatic speech recognizer, which can do all this differentiation. We'll also work on machine translation, which can be customized very quickly depending on the domain. And not only that, it also makes use of speech information that is passed on to it. So if a pause is given to the machine translation system in the text, so these pauses are marked, and then machine can suddenly start doing a much better quality of translation. And finally, text to speech, the speech has all the pitches, all the pitch, it has all the right intonation, so prosody, so to speak. It has ups and downs. So whatever was emphasized in the source language also gets transferred to the target language when the machine is speaking out. So these are the new things that will get done in the medium term of 3 years, 3 to 4 years. And in the long run of 7 to 8 years or more, this is where we will try to reach out to a whole lot of other languages which might not have gotten covered in the first 3 years. So we would cover, my hope is that after the medium term, we will start work, we'll produce systems for all Indian languages, not just scheduled languages, but also pan out to other languages which are also spoken by millions of people in India. They may not be scheduled, but they are certainly very important. So in the long term, we will do a proliferation of research in all these languages. This will require researchers from academic institutions. We would want the startups to come in here and contribute to this. And of course, we will prepare data and make the data available to everybody, whoever wants to do research and use that data. Thank you.
Thank you very much, Professor. So just to let everyone know, we will be taking questions from the audience. So please do type it out in the Q&A box, and I'll ask it to Professor Sangal. But while you are doing that, just one last question from my end, which is actually what you were speaking about at the very end, which is the scope for collaboration between various entities in this ecosystem. So at the research level itself, of course, there are several research institutes that are doing this research, but industry, various players in industry are also doing some level of research on these issues. So where do you see, or in your experience, which I'm sure will be applied to the NLTM, where do you see research institutes and industry coming together?
Yeah, so in this mission, and even otherwise, I feel that we need to have a special arrangement by which the startups can participate in research as well as get benefits out of research which has been produced. So there is something called Center of Excellence, specially designed in the mission. This is a non-profit, these are non-profit entities. Their task is to take research that is being done. They will make it more robust, make it run on different platforms, make the technology more easily, transferable. So that is on one side. On the other side, they will interface with the companies, with the startups, and handhold them, tell them how to use this technology, and those who wish to participate, how to develop this kind of technology. So as entities, these will play a very crucial role, and these are associated already with the academic institutions which are there. These are non-profit entities, so they them will not have themselves in any partial manner. They will be fair to everybody, and they will be able to take the technology and transfer it. Now, there are two kinds of research, if I can use that word, although I don't normally talk about it. There is basic or fundamental research, which then leads to what are known as lab prototypes in our area. And these lab prototypes are then converted into field prototypes. So there is research which goes at that end. And as you try to use these field prototypes, then whole lot of other elements are needed, which also require research. So for example, if you build a machine translation system, now you want, and you give it to, start using it, users start using it, they will come back with many issues they have, many suggestions. And at taking those suggestions, some of those are straightforward implementation issues, but some others require research. So I would say that a natural role for startups would be to be at this end of the pipeline, where basic research gets done by academic institutions or strong R&D groups, and the companies, they do research with respect to usability, with respect to work, translators, workbenches, easy customizability of the tool, which again may require machine learning. So this would be one way of marrying the two. Of course, in the mission, we have no such, we are not drawing a very hard line. There may be some startups who may say, no, I want to participate in basic research. So they are welcome. They are welcome to start working on the research. And as the challenge rounds are conducted, so open national contests are conducted, they can actually participate in them. And if they work well, if they come with a high degree of proficiency, then government will support them with funds also. And hopefully with the recognition they get, they will also become, market leaders. So this whole thing is designed in such a way that we'll have things in the short term and the medium term, and various elements have been put in place such that there is a seamless flow of technology from research to delivery end to the final translators and so on.
Thank you, Professor. That also answers a number of questions we were getting from the audience on how startups can participate. So thank you for that. There's a interesting question just now, which we got from someone who's anonymous. How is this project going to work upon gathering data for parallel translations? So English to Hindi to Marathi, or this anonymous attendee says, or perhaps collecting authenticated data, text to speech. So would you be able to answer this question?
Yes, yes, certainly. So most of the data here that we'll be looking for would be text to text data, because there are three components. They are sort of separate, and we need to work on each one of them separately. So for example, publishers, websites which contain multilingual information for the same subject. So all that data will be ideas to collect that. So publicly available data. We would also be approaching state governments, state academies, state school boards. So really, the language resides in the states. The center is a facilitator, but the users reside in states. They study, they go to school there, they read books, there are novelists, there are readers, and so on. So we go to different states and collect data from there. Now we are not going to stop there. Wherever needed, this data will also be generated, will also be created. So actual translations will be done so that large amounts of data becomes available to everybody at the end of the mission.
Thank you. Thank you, sir. So I'm going to club two questions together because we have about 2 minutes left, but we wanted to get your insights. So the first question from Mufaddal Dahodwala is, what is the best product for converting speech to text using AI? And the second question from Prajwal is, how do we tackle the problem of lack of structured or labeled data to train Indian language NLP models? I know you had referred to this a little bit before, but maybe if we could get some more insights on both these questions. What is the best product,
so
and how do we tackle the problem of unstructured?
So the first question, I will not comment. There are a number of speech recognition systems available, maybe half a dozen, including Google, Microsoft, and a few others. And what we have found is that they perform with different levels of efficiency on different types of data. So if you have, let's say, newspaper articles and that data, you'll have one kind of performance. And the performances then vary very wildly. It's very surprising. So you change the domain and suddenly the performance varies. So this is a result of machine learning. Perhaps when they trained their models, they were biased by the kind of data that was given. So domain bias has come in. Now here we also want to make use of the domain bias. When we are translating for a domain, we would like to make, give the domain data and make use of the system to produce better quality recognition, etc. So with that, I'll move on to the second question, that how do you create structured data? Now, as you know, in NLP, there are three approaches. The first one is the linguistic approach or rule-based approach, where you write rules. You have dictionaries, they are combined together to build a translation system. The second approach is statistical systems. They learn from statistics, and there are probabilistic models that are built, and they can translate. Of course, they not just translate, but they also help in building structured components. For example, part of speech tagging, chunking, sentence analysis, phrasal analysis, semantic role labeling. These are all structured. These are tasks which create structured information. And then, of course, there is a neural machine translation, which is end to end. You start from the source language, you get target language, you have no idea of why it is working. It's just that it works, and then we figure out why it must be working. But very difficult to tweak it or customize it very easily. A lot of research is getting done on that. So what might happen is that these three approaches may actually get combined. So if linguistic or structured information is available, then currently we know statistical systems start working much, much better. But we do not yet know how neural machine translation systems operate with structured data. And So that will be a research effort where if we can use linguistic data with neural models, then we will have a good fluency in the output, but also better accuracy. So this again will be part of our long term. Major advantage is that with linguistic models, with very small amount of data, one can build systems. So if you want to build a system from, Bodo to Manipuri, not too much data is available, and you can go ahead and build it very quickly. You can also customize that system very easily. So these are the advantages of a linguistic system. And the neural system has the advantage that it produces very fluent text, but sometimes the translation is wrong, but the fluency is extremely good. So now if we want to combine the two to get good fluency as well as good accuracy with small amount of training data. So this will be the key. So we hope that in the long term, we will make world contributions to research, because it is not just, there is no speech-to-speech system in the world today, the kind I'm talking about. So through this project, through this mission and time to come, by involving everybody in it, India can become a world leader in speech-to-speech translation. And we'll produce things for the world, for the languages of Africa, for Asia, Latin America. We'll transfer the technology, and India will be known that the country which made translation possible in the world for all languages of the world. Thank you.
We certainly hope so, Professor, that this really catapults India into a leadership position globally. So thank you so much. This has been a wonderful conversation on the NLTM and the prospects and opportunities here. There is a clear plan, medium 1 year, short term 1 year, medium 3 year, and long term not 7, not 20, as you were saying. And it is, I mean, I have taken 4 pages of notes, but to really summarize in 20 seconds, it is something that is going to be truly multi-stakeholders, going to bring in of course, research institutions, but industry and startups will play a role, not just in the deployment and the market aspect, but also on the research. And it's not, I mean, it's going to have the central government, of course, but also various state governments playing a key role. So that's it from this session. Thank you once again for your time, and to everyone attending, we hope that you enjoyed this conversation. Have a good afternoon. Thank you.
Thank you. Thank you.
Thanks a lot, Arindrajit and Professor Sangal. I really do hope that India becomes a focal point for language translation for the world. Up next is a panel discussion on enablement and ecosystem development, R&D collaboration and policy support. The session will be moderated by Ms. Nidhi Pratapneni. A quick introduction about her. She's a Senior Vice President at Wells Fargo. She heads public affairs as well as product analytics and modeling for India and the Philippines. In the past, Nidhi has worked in consulting, retail and tech industries through her role at McKinsey & Company, Safeway, Dunnhumby and Dell. Nidhi, over to you.
Thank you so much. I hope I am audible. Sure. And also checking
yes, sure.
on all the panelists. I see Pius, Professor Mohsem. Are you there and Uday?
Yes, hi.
Okay, okay. So it's been very fascinating listening to all the discussions so far. And in fact, the last point that was raised around, we were talking about vaccine diplomacy. And I guess NLP might be the next frontier where we develop systems and we are able to spread those technologies around the world as well. So really excited to begin this discussion with 3 experts in their field. Good afternoon to all of those who are attending, and a very warm welcome to each of the 3 panelists, and look forward to a really fabulous discussion in this space. I think we are at this confluence of, we have an age-old heritage and cultural complexity that India entails, India and its languages. We have had this unique ability to leapfrog into cutting-edge competencies, and we're also looking at, the power of technology and specifically AI and leveraging it for India. And so, the potential to drive a lot of positive experiences and outcomes for the Indian population. I think the way we have seen in fintech and so many other spaces, and NLP is also, as we have heard over the last 1 hour, another frontier that will, enable a lot of changes in how we experience and we transact goods and services in India. So without much ado, let me get into this discussion on the enablement and development of the NLP ecosystem in India. And we are focusing on three different aspects, and we have people representing those. What I'd like to do, just to start off in a more interesting way, is do a rapid fire, give me 3 bullet points kind of Q&A. And I wanted each of the 3 of you to sort of think about what are the 3 top of mind, either challenges or possibilities that excite you about this space. And as I go along, I will introduce the panelists as well. So I'll start with Mr. Uday Nagaraju. Uday is the founder of AI Policy Labs and a co-founder of Global Policy Insights. He's based in London. Uday?
Thank you, Nidhi. So thank you very much, and very fascinating conversation so far. I've been looking through. So 3 areas which kind of excite me. One is the potential of NLP to address critical governmental issues in terms of how it can influence the public services and how analyzing public feedback, improving predictions, and so far. The second and third are perhaps linked. One is the potential that the multilingual NLP in Indian languages can contribute to inclusive development, breaking all the barriers, access, going to the remote parts. Third is, of course, a link to the second point, which is the NLP advances in vernacular Indian languages, both in terms of text and speech, which can offer to the overall development. Because we see 95% of Indian population is deprived of English, so they're missing out on the benefits, which can utilize the huge internet subscribers and mobile phone users. So these are the 3 main points.
Thank you, Uday. And we would love to go deeper into your expertise in the policy area and how these emerging technologies and their impact on policy and governance. Thank you.
Sure.
Moving on to Professor Mohsem. And the professor is one of the leading scholars in AI in India. He is faculty of the Department of Computer Science and Engineering at IIT Delhi. And he is also the founding head of the School of AI, which I believe has recently been launched. So hello, Professor Mohsem, over to you.
Thank you, Nidhi. And yes, School of AI was launched just 6 months back. 3 things that keep me up at night. So as an NLP researcher, one is access to information. We are drowning in information and we really want to get the machine to play a role of our personal assistant, who we just ask a question in our language and the machine is able to give us the required amount of information, not too much more because we just can't deal with it. So that is one. The second is that for us, language is not in isolation. Language is tied to the physical world. It's ground to the physical world. For machine, that may not be true. So one of the very important research areas that I feel that someday should really take off is language grounding. When I say a book, the machine figures out visually what does that book mean, can touch the book, can lift the book. And so when we interact with any kind of other modality, then the language needs to be grounded in that modality. And that is something that really excites me. And last but not the least, from a more technical point of view, NLP has made a huge amount of progress, but it is still in the shackles of large amounts of annotated data. And so I'm really hoping that tomorrow we are able to create systems where NLP systems can be trained with just very small amounts of training data, like we as humans often learn very fast. And one of the areas we are exploring in that context is neurosymbolic AI, not the current forum for us to discuss too much in depth, but Rajiv also said, can I bring together linguistics, statistics, and neural? In the very same way we are saying, can we bring together neurons and symbols so that we can build these data efficient NLP systems?
Thank you, Professor. It's quite fascinating how so many different disciplines are converging together. I mean, at a very high level, we talk about STEAM as opposed to STEM, but then there are so many different facets to it when you talk about books, what they connote, and so much more. Thank you. And last but not the least, I'd like to introduce Mr. Pius Jha. And Pius brings to us the commercial, the application angle. He has been head of technology and digital solutions for Global Logic. And I think Pius mentions in his own blog that he thrives on working with the technology folks and also connecting them with the requirements of the Fortune 500 companies that they have been serving. And in fact, I saw in the news that Hitachi is about to acquire Global Logic. So congratulations, Pius, on that, and welcome.
Thanks, Nidhi. Yes, it's been a busy few weeks for us getting close to the deal, and we're proud of the kind of valuation we got and the kind of trust that is placed in us. Also, re-emphasizes the fact that we want and do operate at the bleeding edge of technology. I think, like you say, without much ado, coming back to the topic, I would extend from the last point that Mohsem had mentioned in the amount of data that is really drowning us. And, the more NLP brings us closer to a human level intellect, the more afraid we get of the amount of data that we are creating and how do we make sense of it, right? So can machines approximate, can machines, kind of triangulate and get to a human intellect level and make a good judgment call? And how does NLP fit into all of this is one good area to exploit. The second is, how do we make it work so that we make tech for good happen? There's a lot of good that we can do with tech, and technologies like Edge and NLP and machine learning can help us a lot with that. Right? Like we use ML modeling and technologies for pot detection on Indian roads so that we can alert people on what's going on. So what can we do with NLP so that we make tech for good easier? The third is an ethics question. Of course, we'll need to, while we talk about policies and framing policies and stuff like that, we need to be careful about what are the pitholes that we open up while doing that, and are we arming tech in such a manner that we start straying beyond the ethic boundaries. So that is another area while framing policies we should be aware and be thoughtful about.
Sure. And I think the whole AI, is it good or evil, has been a matter of a lot of debate. And what we have seen as, the common user sees that, yes, WhatsApp, Facebook seems to be reading what I write in WhatsApp, and vice versa, perhaps, and also sees a lot of the recommendation engines, Alexa, listening to us. So if we were to talk more about, the positives that this NLP ecosystem can bring, what are those outcomes in very different industries that you can sort of draw out a picture of?
I think, two industries that come top of my mind, Nidhi, are healthcare and education, both in which we can combine NLP, ML, and a bit of edge to give a lot of edge to the solutions that we create, right? One solution that we currently are working on is can we make doctors hands-free while they interact with patients, right? So, while a doctor is assessing a patient, a lot of bandwidth goes into the hands writing on a pad and trying to create a prescription that will be handed over to the person. Now, can we interpret intelligently what the doctor means to prescribe, and can we get that down onto a digital form while the doctor just keeps speaking, right? And if you are able to process what is being spelled and work with that, then since the information is already digital, while the person is in room and the doctor is there, can we apply, and we should be able to apply edge technologies to warn if a part of the prescription is not fully correct. Let's say, there is a flu circulating in that area, or the patient has a history of something that the doctor has kind of, ignored or not paid full attention to. Since the information is already digital while you're operating on it, will we be able to alert the doctor that, there is some issue that has happened, right? That is a use case that, sprung up as pretty useful amongst what we are currently working on. And there would be a plethora of use cases like this, where you could apply what is being said, what exists, and you could team it with edge technologies and be able to give very insightful outlook or thoughts on what's happening. The second very obvious area seems like, uh, we have been working to applying emotional intelligence on social media posts, right? And kind of analyzing those posts to identify pockets that could be miscreants, could create trouble and do stuff like that. With a lot of stuff going voice and going video in those posts, will soon lose our edge if we keep operating on text that is written. With NLP coming in, and with our ability to be able to interpret what is being said, interpret the tone of and tenor of what is being said, will we be able to operate on videos and audios in a similar manner as we were on text, and still be able to find miscreants or find stuff that could cause unrest in societies. So these are the kind of themes or use cases that keep us busy, and that we like dabbling or exploring in, we are working on, so that we could utilize this set of technologies to our advantage.
Let me add a couple of thoughts here to what you said. So I mean, I think there's a simple abstraction here. For the last 30, 40, 50 years, humans have been speaking to machines in machine language. I mean, we program in computers language. We don't speak in C or C++ or Java between two humans, right? We speak only to machine like that. But our language of communication has always been, English, Hindi, whatever one of our languages. And I think the time is slowly coming when we would be interacting with machines in our language. Now, whether the time is now or 10 years from now, 15 years from now, it's not very clear. Different verticals may move slowly and fast. But for example, we see the proliferation of chatbots in pretty much everything. And that's just NLP. And that is the place where instead of filling a form, we can just go on WhatsApp or whatever Telegram channel and let them know that this is what we want to buy, and this is the problem, and the machine deals with it to a large extent, or the human takes over later. I mean, we are reaching an era where we will be talking to machines in our language. Moreover, we are also reaching an era where we will be speaking to each other through the medium of machine, right? Whether it be a Gujarati Italian speaker coming together, or whether it be the machine looking at social media posts, because we are sharing our thoughts and views on social media, but there is so much of social media, and so the NLP will be dealing with it and look. So whenever the machine has to deal with whatever human thinks and expresses, the human would have always expressed it in their language, and the machine would add value after understanding the human language. And which, if you take this view, you get into any vertical, any kind of, if it's business processes, all the processes are listed in human language. If you want machine to help, machine will have to understand it. If you look at legal domain, all the case histories are written in human language. And if you want a machine to help the judges or the lawyers, again, so you start thinking about any vertical, you will find that all the information, all the knowledge is in human language, all the communication is in human language, and the machine will be able to add a ton of value there. So I think the sky is the limit when we talk about the value of NLP.
So I'll just yeah, go ahead, Uday. Yeah, I was just trying to bring in your policy. Yeah.
Okay. And I'll just add to what both Mohsem and Pius have mentioned, and more in kind of very simple examples. I mean, not sounding too ambitious, I'll give 4 examples from 4 different parts of India. An old lady from Bengal, for instance, who can only speak in Bengali, interacts with a health application about an eye problem. The application then analyzes, and after some back and forth, suggests some remedial measures, increasing the lady's awareness and of the issue and referring to an appropriate specialist, for instance. A second example could be a farmer from a remote village in Gujarat searches in Gujarati to find information on precise measurement of water and fertilizer input for their crop. This can significantly affect their cost and the production and have efficiency in production. Third, a visually impaired person woman who can only communicate in Telugu starts utilizing the language technologies to do many things like reading, shopping, and significantly increasing the quality of life, productivity, and decreasing the dependency on others. And finally, a lady from Uttar Pradesh, interacts with a mental health application in Hindi, explaining her symptoms. The application asks basic details, analyzes, and responds with appropriate first level information. So these were examples, where these innovations can, one, significantly improve the quality of life. They can increase productivity and overall well-being.
Sure. So Uday, at the same time, one from a policy perspective, how does policy need to evolve to, one, enable this, and also to set up a framework to ensure that things don't go out of control? And what is the global versus Indian national dialogue or challenge that you're seeing on the policy front?
Yeah. So, when we talk about policy on NLP or AI in general, it changes from country to country, firstly. Then the policy considerations must be two-pronged. On one hand, there should be measures for building the required skills and capacity, research, and creating the ecosystem for using the benefits of AI both in public and private sector, towards inclusive development and social good. On the other hand, policy must also consider the potential risks and possibility of societal harms, including aspects of ethics, safety, security, privacy, and bias. Now, how we achieve that? The specific steps could be, first one, investment into basic and applied research and development for NLP in Indian languages through research grants specific to NLP in Indian languages, and research institutions also looking at these. The recent budget allocation to NRF, the National Research Foundation, is a great development, and the National Language Translation Mission's efforts could be strengthened if there are grants specific to each Indian language. The second one is through talent attraction, development, and retainment, which is very, very important to do further research and to also maintain the kind of leadership within AI. It's the retainment of skills in AI is very important. The third one is the future of work. As we all know, AI is going to bring new jobs, but at the same time, it could displace many jobs. So we have to. So the governments could look into, one is kind of research into what are the types of jobs that will be displaced. Then two, to address the efforts, and how long are we looking? 1 year term? Are we looking 2 years term? And what is it in the long term? Then the efforts there need to be to address that. Perhaps the governments need to invest, one, in STEM education, two is national retraining programs, and also impact on lifelong learning. However, there could be some sections of the society, perhaps someone who is already at a certain age or with only certain level of education, perhaps might be difficult to pick up certain new skills compared to, say, perhaps a young person who's a Mohsem student at IIT Delhi. Perhaps it's much it might be different sections of society. When we looked at 95% of Indians are deprived of English and many other things. Another area is looking at how AI could be used, NLP could be used in the governmental sectors in influencing the policy making itself. If you see that UAE has a ministry in AI, perhaps the only government in the world to have an AI ministry, something that can look at AI for public administration and also improve the overall policy, not just policy on AI, but AI improving the actual policy itself. And then the ethics and regulation, the most important bit, which you have alluded to, and you and others have alluded to. So for these, there are ethical codes and standards that are being developed across international organizations. Those need to be looked at. Now, the global versus local narrative. If we see at a global level, many countries have launched their national strategies, and there is bound to be competition to win AI investment. That's the nature of the game. However, if we see, there are some initiatives which are like non-competitive initiatives, like Global Partnership on Artificial Intelligence, which is run by OECD, where India is a founding member. This body looks at AI, responsible AI, the data governance, future of work, and these areas, bringing in key experts. So perhaps that's also another some of these platforms where the frameworks are being developed. But at the same time, those frameworks might not exactly work in India because our context is different. Our the rich languages and the population that we have, it's very different. So these have to be fit in with the local context, the local socio-economic context, the geography, the diversity. It has to align with the national priorities and also with the institutional complexity within the country.
And in fact, just to ensure that we are, reflecting each diverse aspect of the country and multiple languages, your point on investing by language in research, I think that was quite interesting. And I'll, move on to Professor Mohsem to talk about the research landscape and what does it look like today. Are you seeing, a lot of work done more in certain Indian languages than others? What is being done to accelerate, the research to application and that whole feedback cycle in this space?
Sure. Let's see. So first of all, a very interesting suggestion Uday on the funding per language. But we have to realize that NLP works in two different ways. One way in which NLP works is somebody puts together a big corpus, which is annotated, on the basis of which some machine learning algorithm typically takes over, right? Of course, you can bring in some syntax and language specific idiosyncrasies and so on and so forth. Nobody's disagreeing with that. So if we put in the amount of effort that you are talking about in creating these data resources, then I think it can be a game changer. On the other hand, the algorithms will look pretty much the same whether we are talking about Gujarati or whether we are talking about Kannada. So I think it is important to distinguish the two, to separate the amount of funding that needs to go into creating language specific data resources, absolutely, but not specific funding for language, different languages for algorithms. The algorithms need to be typically generic and probably applicable to all possible languages. That is one point I wanted to add to your comment. Talking about the landscape, Nidhi, I think research really happens because of three things coming together today, at least modern AI research. One is data, one is compute, and one is the people who understand the deep machine learning algorithms and are able to use the data to train the machine learning system using the compute at their disposal. Unfortunately, and I'm a little bit sad to say this, but India is a little bit behind in all three respects. You may have thought that we will have lots of data, and we do. There's no question about it. But we don't have lots of annotated data. I think that's the important distinction. So we have and this happens to me so many times when a company approaches us or somebody approaches us who's not from AI, saying, look, I have so much data. Why can you not make use of this and do AI on top of it? And it becomes very hard for me to explain that whatever behavior, whatever functionality you want from AI, right? You want input output pairs to be annotated. Often they only have the input, they never have the output which can be used to train the system. And that is where a lot of the talks get derailed. So what I have felt is that people are talking about data, and I think the government is also thinking about investing in data resources. I think that is the first thing we need to do. The second very important thing is compute. Now you may be surprised or not to hear that GPT-3, which really created such a furor that coming out of OpenAI, and suddenly it started doing things that nobody believed was possible. If I were to retrain GPT-3 using exact methodology that they have and exact data at their disposal, it will take us $4.6 million of compute to just retrain GPT-3. It is mind-boggling to think about. OpenAI can do it because they have been heavily funded by such a large venture capitalist and so on and so forth. I don't think even Stanford can think about training GPT-3 from scratch, and definitely nobody in India, and often probably the rank 21 to plus universities even in the US cannot think about that. We are really in research fighting a game where there are so many people. There's an inflow of people that has come into AI. Lots of amazing people have come into AI. Quality of research has gone up. But as researchers, in order to stand our ground, we need to move extremely fast, much faster than what we had to move 5-7 years ago. And availability of high volume compute is incredibly essential right now. GPU resources are scantily available in the country. And I think the government is really working hard on this aspect of it. Niti Aayog called it the Aravat. I think it's a beautiful name, just the big elephant which is needed to really make this AI work. And I think the government is still thinking about how to distribute the money, what mechanisms. But I'm hoping that 2 years down the line, when we talk again in some panel, we have many supercomputer clusters available in the country which we can all plug into and actually train our models and move faster. Last but not the least are the people who actually understand the technology to its depth. This happens to me so many times. A startup comes to me and says, look, we have this one data scientist who is not really trained in AI, but he's picked it up and he's stuck somewhere. How do we get around this problem? And look, you have to realize that, AI is a mathematically sophisticated field. NLP is a mathematically sophisticated field. And if you are stuck somewhere, you cannot look at the level of API calls. You have to go inside. You have to think, what is the math? Maybe a standard CNN or a standard transformer is not going to work for your problem. Maybe there's a special structure in the problem. You need to innovate. And that is where I feel that if you count the number of NLP researchers who are high quality NLP researchers in our country, and when I say high quality, it's very simple. They publish at ACL, NACL, EMNLP. These are the top conferences in the world for NLP. I will be able to count on two fingers of my hand. That's it. Two hands, your fingers of my two hands. That's it. We have very, very small number of very high quality NLP researchers in our country. And we need to work very hard to bring people back in, because even if it's startups, whether it is big corporate offices, everybody would need some support coming from the deep end of technology, deep end of research, and we don't have enough support to give. So I am, unfortunately, I'm sounding a little negative. I don't mean to be negative at all. I really want us to succeed in the long run. And so therefore, I hope that collectively we work towards bringing these three verticals in shape, so that the research infrastructure strengthens, the corporate infrastructure will strengthen, because capacity building always happens top down. If I train 100 people, they can become teachers later and they can train further 100,000 people, or they can take jobs. But if you pick it up from Coursera and so on, you will not get the depths of the field until you'll have to really struggle. You can possibly get it, but you have to really struggle. So that's my sort of quick response to you.
I think it's a pretty important point, Nidhi, and right at this forum, right? As against quite a few technologies that have come in the last few years, where the basic structure of framework exists and people can pick it up and kind of utilize the APIs to create wonders, or create, like people could create mobile apps, right? This is a deeper technology, so people will need to be trained bottom up. Which is what many people are not doing, and thus they fail or create results that are inadequate, and then get surprised on why they're facing the challenge.
And Piyush, do you see that in the corporate world, like with the Microsofts and the Googles, depending so much on their their R&D investments in India, are they able to invest much more than what, say, Professor Mohsem may be seeing in the non-corporate side of the Indian landscape?
So I think from a corporate perspective also, there is a divide, right? There is one part of the ecosystem which feels that people could walk their way through NLP, and they would rather invest in picking people or hiring people and working their way through this. At times they would succeed. They would be able to find a few guys who are pretty good and do the job, but more often than not, they do not succeed. Then there is a second segment which does exist at companies like Google or Microsoft, which understands there's a much deeper giant. There are COEs within, and we are ourselves trying to create a COE that operates on the trijunction of technologies around ML, Edge, and NLP. But it is not easy, I can tell you that. So I think there will be an investment on that, and that will be something that is significant. And then there is a third segment, right, which kind of, I'm almost sure, will give up on NLP or whatever it produces in a few quarters, after seeing that it doesn't materialize what they are trying to get around. And then they'll wait a couple of years for this technology to become more mainstream, and then be laggard adapters, which is not a bad thing per se for the corporate world, but that will not be something that the corporate leaders will use.
Okay. Were there any views on policy levers that can help with this?
I think one is the international cooperation one to begin with, and general kind of cooperation in terms of any kind of research everywhere. Of course, we're talking specific about Indian languages, but the experience that we get from across the world is one that is useful. Second, one thing what I see is the private sector is generally not kind of included so much into conversations in when we talk about sustainable development goals or inclusive development. But I feel that private sector does add, and it has reinforced particularly with the pandemic. If we see just going on to pandemic, the gap for sustainable development goals was around 2.5 trillion US dollars per annum. That was increased to 4.2 but just post the as we moved into the pandemic. Now I think that is where the private sector, which kind of has the expertise, not finance is only one aspect, but the expertise. One aspect that Pius was also referring to, that and the companies themselves have certain amount of research, etc. So there, that is the expertise that the private sector can definitely bring in, and they need to be brought into these conversations, which I generally think is not done across the world, not so much as there could be when we talk about research and academic conversations.
Mm-hmm. Sure. Thank you. Then I know that we are a little over, so I think I will try and wrap up in 3 to 5 minutes, if that's okay. The one or two things I wanted to touch upon, was the idea of what are some of the use cases that you're seeing which are really stellar. So perhaps on the research side, Mohsem or Pius, on the more commercial startup space, any really novel applications that you're seeing that you can share with us?
Sure. So let me share from the research side. I mean, research obviously runs maybe 4 to 5 years ahead of the curve. So some of those things will eventually translate. But one of the things that happened in the last 2 years is this advent of pre-trained language models. I think everybody knows this. Even Manish Gupta talked about BERT as one of those poster child things that Google have done, and has revolutionized the field to a large extent. So now these pre-trained language models are becoming more and more multilingual. And that's very interesting, because that basically says that, look, you give me any language in any sentences, any language, I will create some representation for that sentence, which will be similar to a similar sentence in a different language. All the languages will come together in a single sort of a multilingual unified model. If we are able to do this effectively, then I think in the long run, this need for annotated parallel training corpus is going to just go away or become much less. And I think I'm really putting a lot of my hopes on that side of things. The second thing I think that is becoming very interesting is this whole idea that you tell me what the program needs to be written and the machine will write the program for you. Right? So in up until now, we would write the program. Humans would be writing programs for the machines. Now we will just give the specifications and the machine will discover the program. So this is called code generation. And what is code? It's a series of symbols. So you can think of it as text in some weird language, and each curly bracket is a word, and each equal to and so on is a word. And so you can start thinking about a machine just like it can generate a language when it is translating. You can think of it as machine translation system, where the input language is what I told the machine to do, and the output language is the machine language itself. So that will be very interesting, and that's something that is starting to happen. And last but not the least, closely associated with multilingual pre-trained models is this general idea of zero-shot learning, where I don't give you annotated data. I explain the task in human language, and then I give you an input and I expect the machine to output the correct answer. I couldn't have imagined this would be possible until I saw the recent paper that came out of GPT-3. So this is mind-boggling stuff even for me. And I hope that if this sort of takes off, if more people spend like tens of millions of dollars in creating these very large models, maybe the need for a lot of other NLP research would be obviated, and we will just be able to do zero-shot learning. But these are the three things from the research side.
From an industry use case perspective, we are looking at certainly a lot of applications of NLP in healthcare, and wherever somebody would consult and there exists a language barrier. In Indian context, it will be very useful because India is a very obviously multilingual country. The second sector that we see a lot of interest, and we have started doing a lot of programs around, is in education. Because with the advent of, and of course assisted by COVID, uh, the education, or the onlineness of the education, is now a given. People don't really need to be in classrooms to be doing that all the time. Since you have already moved it online, and you assume that there will be a lot of online activity, if we are able to crush across the language barriers, it will make it a lot easier on everybody. The need for really trained individuals in the language that you speak will reduce, which kind of starts making it easy for students. That would go ahead and do wonders for the higher education process in India. It'll make a lot of very niche education available to a lot of people. And then, of course, there's this usage in operating on top of social media, like we spoke about earlier, or in sectors around retail, which, it's commodity market, but it makes a lot of things a lot easier for people.
And I think when you talk about social media, and I'll wrap up here with a final question to Uday, is around, Professor Mohsem talks about, like, the world being, the machine understands everything, and we are speaking to machines, and we also know about the negative images that have been created around, malintent driving some of this. So, right, you have NLP where there is perfect understanding, but how that perfect understanding is used to drive the wrong actions. So Uday, what is this policy impetus towards balancing, open self-regulation versus the external controls that have to be placed on, NLP, AI, in order to, bring in responsible AI?
Yeah, so very very nice question there, Nidhi. It's just that as Professor Mohsem was mentioning, mentioning about AI programs being able to program themselves, as that itself poses. So earlier when we were talking about AI and NLP displacing people in other fields, we didn't really consider displacing programmers. But this innovation could perhaps, we'll have to consider, it could displace programmers as well. But anyway, speaking seriously. I think there should, as you very well right said, there should be a balance between self-regulation and imposed regulation. Now that could be possible. The first step, of course, is self-regulation. A possibility could be a regulatory framework where wherein like an independent body that reports to Parliament. Certain countries are trying to follow, not specific for AI, but in general for online and others. But what happens with anything? What I see is governments are playing catch up, particularly because of the way incremental innovations are posing new questions, and that needs anticipatory regulation even before something comes into place. Just as the perfect example is what the latest innovation that the professor just mentioned, and that has posed some questions to us immediately as to what wouldn't. But of course, this is very very important. These innovations are very important, but the regulatory frameworks have to catch up, and governments are nowhere near it, to be honest, at this point of time. That is where international cooperation comes into picture, bringing in key stakeholders across various sectors, including the private sector.
Thank you.
Can I quickly add something to this? I think this is a very important point, and I know we are out of time, so I'll just take 30 seconds.
Sure.
But I do want to point out two things. A lot of researchers have recently shown that claimed that many jobs will be displaced, but many new, and in fact more new jobs will be created because of AI and NLP. I think we should definitely look at those reports very seriously, because yes, we are worried about jobs going away, but we should realize that in the next generation, we will have lots of jobs to do. And so it is more about a rehabilitation of the people who are displaced. Point number two, a lot of things I talked about are research, they may or may not really happen in the long run. But more importantly, we should always think about technology and its use separately. Where should we use technology? I think should fall under the purview of regulation. So for example, if today you say that every house should have a dishwasher, automatic dishwasher, I'm going to say no, because we really thrive on having our cooks and maids actually, and they get the money through it, and it is important for the economy. But if I were in Japan saying the same thing, I would say absolutely, there are no people who can do these jobs. Let's have automation there. So right, like we have had the automation debate and we have dealt with it, I do not believe that AI debate is going to be very different. I do agree that the role of regulation is going to be important. What application makes sense in a certain country, in a certain setting, is something that the regulation would definitely help with.
Thank you. Thank you, Professor Mohsem. And with that, we wind up. And the operative word is anticipation, I think. So anticipation of a lot of exciting things and anticipatory regulation for some of us. So with that, a very good afternoon to all of you. Thank you.
Thanks a lot, Nidhi, and all our panel members. I think what Professor Mohsem mentioned about a common framework for language translation that can be potentially workable with any human language, I think that indeed seems very exciting and hopefully will solve a lot of problems related to NLP. So thank you, everyone. This has been a wonderful session. So that was day one of NLP week. And I want to mention to everyone that this is only the beginning of what will be a comprehensive coverage of India-specific NLP, which will include showcases and workshops and more. And just to give a peek to everybody on what's to follow, on day one, we are going to talk about developing high-quality speech-to-speech machine translation, and which will be given by Dr. Pushpak Bhattacharya, who is a professor at IIT Bombay. He will share with us an introduction to Bhau-Bhashak mission, which will also include code walkthrough. Day three will have a slew of presentations by founders of some of the leading startups in the space. And lastly, day four, a session by Amazon on driving omni-channel customer engagement through text-to-speech. Do join in. I would encourage everybody from today's session to participate in the sessions to follow. It's going to be a very exciting journey ahead. And thank you, everybody, for joining in, and also the panel members who were so kind to take on questions and conduct such an exciting panel. Thank you.
Thank you.